parametric test. Pick legacy dialogues. Okay, legacy dialogues. So here you have one sample, two independent sample, and you have K independent samples. Okay, so pick K independent samples. Because here is actually what you call that, more than two independent samples, right? If you use independent sample t-test and you want to use the non-parametric, you can pick this one. But for ANOVA, you have to pick K independent samples. Okay, so you will have this interface. Okay, you have this interface, and here you put the group. Okay, here you put the group. Okay, so grouping variable, you put the group. So once you put the group, as usual, you have to put the what you call that, the grouping details. So the minimum one is 1, the maximum is 3, since you have 3 groups. If let's say you have 4 groups, you need to put minimum 1, maximum 4. It depends on how many groups you have. Okay, so maximum is the number of group that you have or you want to compare. Okay, so next you click continue. Okay, click continue, and then this you put in the test variable list. The data you put in the test variable list. Okay, so now you need to make sure that you tick the Kruskal-Wallis hash here. Okay, so you click OK once you have put everything here. Okay, so click OK, and you will get the data. So this is the data. Okay, so this is the data for the Kruskal-Wallis test. This is the rank. Okay, the rank. This is not the mean value that you calculate using whatever the formula that you use before you during the descriptive statistic. This is the ranking, the mean of the ranking. Okay, so this is the test statistics where this is the Kruskal-Wallis value, this is the degree of freedom, and this is the significant value. Okay, the significant value or your p value. Okay, so here you can see that this is the p value 0.035. Okay, 0.035, is it less or is it more than 0.05? Is it less or more than 0.05?
Less, doctor.
It's less than 0.05. Then, using whatever you've learned before, does the null hypothesis rejected or we fail to reject the null hypothesis? If it less than 0.05, do we need to reject the null hypothesis?
Reject.
Reject. Okay, so we reject the null hypothesis. So we can see now that if we reject the null hypothesis, meaning that there is a difference lah, okay, between the groups. Okay, so this is what we have to do for Kruskal-Wallis test. Okay, so if you want to use Kruskal-Wallis test, this is what you need to do to analyze the data for Kruskal-Wallis. Okay, using SPSS. Okay. Okay, so let's continue with the next analysis. Okay, with the net analysis, just now we've looked at the one-way ANOVA. Okay, one-way ANOVA, like I said before, it is where you have 3 groups. Okay, more than 2 groups. But in two-way ANOVA, it is much more what do you call it? Much more difficult, a little bit difficult than one-way ANOVA, because it does not only have more than 3 groups, but it have more than 1 independent variable. Okay, You have more than one independent variable. So let's say in your research, if let's say you want to, okay, for me, I want to, the dependent variable, okay, let me look, let me write here. The DV is the test mark of quanti and quali quizzes. Okay, and the IV just now, okay, for ANOVA, I mentioned just now the IV is the set, right? So we have set 1, set 2, and set 3, okay? And I want to add another IV, which is gender. So we have male and we have female. So in this case, we have two factors here, or two IV. For one-way ANOVA, okay, for one-way ANOVA, we only identify this. This is for one-way ANOVA. Okay, but if you want to add another variables, okay, or another factors here, this is where you have to use two-way ANOVA. Okay, and if let's say, okay, wait. Okay, sorry. I need to mute my phone. Okay, so this is where you have to use two-way ANOVA. Okay. Wait. Sorry, wait. Hello, Syawal. Ada kelas. Nanti kau balik boleh? Okay, thank you. All right. So, where is it? Okay, wait. Okay, so let's start again. Okay, so if you have more than one variable, this is where you have to use two-way ANOVA. Okay, if let's say you want to test for set, gender, or maybe you want to test for maybe what else we can test for? Maybe different background, right? Different background, like maybe people with mathematics background and people with non-mathematics background, let's say, right? So we can have like maybe different background. So mathematics background, non-mathematics background, let's say. So if you have more than that, you have 4 independent variable, 5 independent variable, you can use two-way ANOVA. Okay, so this is for two-way ANOVA. For one-way ANOVA, you have more than 2 groups. For two-way ANOVA, you have more 2 or more factors or IV. Okay, so this is what two-way ANOVA is. Okay, so can you understand now the differences between one-way ANOVA and two-way ANOVA? Okay, if there's anyone who doesn't understand, you can always ask me right away. Okay, right away. So later I don't have to like go back and explain again. Okay, so you can always raise your hand, or you can just talk and ask if you have any question. Okay, so that's the differences between one-way ANOVA and two-way ANOVA. All right, so like I said before, the ANOVA problem that we have discussed before, okay, just now, and also a few weeks ago, has only one dependent variable and one independent variable, okay, or we call it as factors too lah. Okay, so what if we want to use 2 or more independent variable, like I said before, like gender, sets, backgrounds, and things like that? So do we have to run few or multiple ANOVA and t-tests and things like that? It's very, what do you call that, hard work, and it's very complicated. Let's say if you want to compare this and that, you know, if you conducted multiple analyses, it will be very hard for you to somehow interpret the results later. So that's why we have two-way ANOVA, where we can analyze it using one analysis. Okay, using one analysis, we can combine everything, and it will be much easier for us to interpret the data later. Okay, so here we will only look at the case of two independent variables. Okay, two independent variables. For now, we will look at the case of two independent variables. But if you have more than two independent variables, like I mentioned before, you have, let's say you have set, you have gender, you have different backgrounds. So now you have three, right? Three IV. Or maybe you want to add maybe more independent variables here, 5, 6. The process is still the same. Okay, the process is still the same as what we are going to look after this. Okay, so but for now, we are going to look at the case of two independent variables. Okay, two independent variables. So in two-way ANOVA, we examine the effects of two independent variables. And unlike two-way ANOVA, for one-way ANOVA, you are only allowed to have 3 groups and above. You cannot have 2 groups, because if you have 2 groups, it's t-test, right? It's t-test. But for one-way ANOVA, you are allowed to have 3 groups and above. But for one-way ANOVA, you can have 2 groups, 3 groups, and so on, because you are examining the effects of many variables. Just like what I said before, right? The set, you can have 1, 2, 3 groups. And if the second variable, you can have gender, which is male and female. It doesn't matter. In one-way ANOVA, no, you cannot have that. Okay, you cannot use gender. But in two-way ANOVA, you can use gender. Okay, you can use gender, which is only have 2 groups. Okay, so in two-way ANOVA, like I said before, the effects of 2 independent variables can be studied simultaneously. So meaning that you don't have to conduct multiple analysis or independent analysis. You cannot, you don't have to do like separate analysis for each of the factors. So two-way ANOVA, it can show you the effects of separate factors, or the factors separately. Maybe you want to see only gender, you want to see only sex, you can do that. And the bonus point is you can also see the effect of interaction between each factor. Let's say you want to see if male in set 1, how is their performance. You can also see that the interaction effects between each factor. Okay, you can see it separately, and you can see the interactions. That's the bonus point of two-way ANOVA. Okay, so that's why, okay, we have to come back to our research objective for two-way ANOVA, which is a bit complicated than one-way ANOVA. You have to develop 3 research questions in ANOVA, in two-way ANOVA, which is the first one is the individual effect. Okay, the individual effect. Factor A, factor B. So you have the first research question, second research question. This is the individual effect. If let's say you have 3 factors or 3 independent variable, you will have 3 individual effects, research questions for the effect. Okay, so this is in the case of 2 factors. Okay, like I said before, we are going to look at the case of 2 factors or 2 independent variables. So you have the independent research question for the independent effect, which is the first one for factor A, the second one for factor B. Okay, so the research question should be the effect of factor A on the dependent variable. Okay, if we look at the example that I give to you, this one. So I want to okay, the sex and the gender. So if you look at here, this should be what is the effect of sex on the performance, quiz performance. Okay, and the second research question would be, what is the effect of gender on the quiz performance? That should be the research question first and the second research question. And there will be the third research question about the interaction effects. Okay, interaction effects. This is all. Okay, this is all. You can choose how to. You can choose to write like the first one or the second one. Okay, usually I will choose to write the second one. To what extent is there an interaction between sex and gender? That is where we look at the interaction effects between sex and gender. Okay, so when you have when you are going to do the one-way ANOVA, meaning that you need to have one set for each question, which is 3 sets of hypotheses, three sets of question. Okay, so hypotheses, these you need to have one hypothesis, these you need to have one hypothesis, these you need to have one hypothesis. So you need to have one hypothesis for each questions. Okay, so let me repeat again. For two-way ANOVA, you need to have 3 research questions. Okay, which is the first one is the main effect. We call it as main effect. And then the second one is also main effect for the second factor. And the last one is for the interaction effect. This is in the case if you have 2 factors. Okay, I repeat again. This is if you have 2 factors or 2 independent variables. Okay. All right, so this is how you write the hypothesis. Okay, this is the hypothesis null and hypothesis alternative for main effect. Okay, there is no difference in the mean of dependent variable across factor A. There is a difference in the mean of dependent variable across factor A. Okay, yeah. So this is the main effect. Okay. Okay. So this is how you write the main effect hypothesis. Okay. Interaction effect of factor A and factor B. The hypothesis should be there is no interaction effect between factor A and factor B. There is no interaction effect between factor A and factor B. So, like I mentioned before, it depends on which hypothesis you want to use. If you want to use hypothesis null, like I said before, there is no difference. If you want to use the alternative hypothesis, you have to claim there is a difference. Okay? So, like I said before, I repeat again, 3 hypotheses for 3 research questions. Okay? So, let's look at this example. So it says here that a researcher wanted to study the effects of teaching methods and gender on students' mathematics achievement. So this is the effects of teaching methods. So you can see here, teaching methods is the IV. Okay? And gender. Gender is also the IV. So this case, we have two IV. Okay, on students mathematics achievement, this is the DV. Okay, this is the DV. Okay, so students, this study involved 60 high school. Okay, this is the sample. Students were divided into 2 groups based on teaching methods. So you have 2 groups here, teaching methods, and also gender. We have also 2 groups. Okay, so namely traditional and technology-based teaching learning method, and then gender, male and female. So all the students were given a mathematics achievement test. So we use two-way ANOVA. So in this case, we have 2 groups. Okay, we have IV teaching method. So we have 1 group for traditional, second group for technology. And then we have gender, male and female. Okay, this is the both of the IV. Okay, so we have 2 factors here. So research question here, first of all, you need to look at the main effect. Like I said before, is there a significant difference in the mean mathematic achievement, which is the DV? between students using traditional teaching methods and technology-based learning methods. So this is for the teaching method, main effect for the teaching method. And then is there a significant difference in the mean mathematics achievement between male and female student? This is for the gender. Okay, so both of these is the main effect. Main effect. Okay, and the third one here, this part is the interaction effect. Because you can see here, is there a significant interaction effect between teaching methods and gender? Okay, so now we are looking at the interaction effect between teaching methods and gender. So this is how you write your research questions for the two-way ANOVA analysis. Okay, so you have the main effect and the interaction effect. Okay, so this is the hypothesis for the main effect and the interaction effect. So you can see here the effect of teaching method. So there is no significant difference, okay, for hypothesis now. There is no significant difference for effect of gender, and there is no significant interaction effect. Okay, between teaching method or gender and something like that lah. Okay, so you write based on the independent variables that you use in your research. So this is another example. Okay, can you tell me what is the independent variable in this example? Can you tell me what is the independent variable in this research? What is the first IV?
Teaching using digital applications,
Okay, yes.
and the other IV is without the use of technology. Teaching without the use of technology.
Okay. Unfortunately, that is a wrong answer. Okay. So that is actually what you mentioned just now is actually the groups, not the independent variable. Okay. So the independent variable here, can someone else tell me what is the independent variable here? The first one and the second one?
Effects of technology used in teaching,
Okay.
and the other one is students' motivation levels.
All right. Okay. Effects of technology used in teaching. What is the group? What is the group for the effects of technology use? The first one?
Digital and non-digital.
Okay, digital and non-digital. And the second one for the motivation levels?
High and low.
High and low motivation. All right, good answer. Okay, so I hope everyone else can somehow understand how to extract the variable from the, the situation or whatever the scenario here. Okay, so what is the DV here? What is the DV?
Mathematics achievement.
Mathematics achievement. All right. So you have two IV, which is the effects of technology use, and you have and student motivation level, and your DV is mathematics achievement. So this is how you identify. So for you to be able to write a precise research question, make sure if it was me, I will write first what is the IV and what is the group, and then what is the DV, so that it will be easier for me to write the research question later. Okay, so the first main effect, okay, the first main effect, research question for main effect first. Okay, can someone tell me what is the research question for effects of technology use? Anyone?
Maybe what is the effect of technology used in teaching or mathematics achievement.
Okay, all right. So how to write a proper research question should be you can refer here. Is there a significant difference in the mean mathematics achievement score between students who are learning using technology and students who are not learning using technology? So that would be the proper way to write the research questions. Okay? And the second one for motivation levels, can someone tell me what is the research question? To identify what? Research question, is there? Can someone continue? Is there?
Is there a significant difference
Okay.
in the
Mean score.
mean score of mathematics achievement
Okay. Between?
between high and low motivation levels?
Okay, yeah, all right. Very good. Okay, and then the last one, can someone tell me the research questions for the interaction effect? Is there a significant? Someone continue?
Is there a significant difference
Significant
effect
interaction effects.
between
Uh-uh.
effects of technology used in teaching and students' motivation levels?
Yes, all right. So that's how you write your research questions for the any situation or scenario that you are going to do in your research for two-way ANOVA. Okay, two-way ANOVA. So for hypothesis, you can refer to these slides. Okay, how to write the proper hypothesis for your research questions. So I repeat again. Okay, for two independent variables, you need to have three research questions and three sets of three hypotheses. Okay. Okay, let's look at the assumptions. Okay, the assumptions. So, the population from which a sample was obtained must be approximately normally distributed. As usual, you need to have a normally distributed data. Samples must be independent. Like I said before, independence of observation. Variance of the population must be equal, same as one-way ANOVA, homogeneity of variance, and the group must have same sample size. You cannot use like the first group have 3 people, the second group have 20 people, the third group have 40 people. No, you need to have similar sample size. Okay, so if you decide that you want to use this, or you want to do a comparison between group, you need to make sure that there is no huge difference between groups. Okay, because if there is a huge difference between groups, there might be like bias in the analysis later. Okay, and we don't want to report a biased result. Okay. Okay, so this is the two-way ANOVA summary table. Okay, just like what we have looked before in the one-way ANOVA. Okay, we have the sum of square, degrees of freedom, mean squares, and F statistics here. Okay, F statistic here is the value of the ANOVA itself lah. Okay, F statistic. If t-test, we use T statistic. If ANOVA, we use F statistic. Okay, this is the formula for each of it. So you can refer this later when you are doing the quiz later. If let's say they ask you to calculate like this one, like we've done in our one-way ANOVA. Where is it? Do they have the example here? Or they don't have the example for the calculation like we did in the one-way ANOVA last time, right? But in case if they ask you to find whatever the value, what is the SSA, what is the SSB, something like that, right? Like we've done in the one-way ANOVA last time. This one. Right, how many groups are there, how many observations are there, what is the SSB, things like this, you can refer to this this table. Okay, you can refer to this table. Later I will give you one exercise. I will give you one exercise this week, okay, for you to answer, so that you can somehow train yourself how to use this formula, okay? And you can discuss with your friend, okay? You can discuss with your friend I will try to create one questions for you later. Since they don't give the questions to us, so I will try to create the questions after this and give to you. Okay. All right. So this one I will give the questions later as an exercises for this week. All right. So how to do the two-way ANOVA using SPSS? Okay. Let me see if I have the data set for this. Let me see. Do I have the data set? Okay. Not this one. 2024, 2025. New. Okay. Okay. I have it. I think I do have it. Regression, independent t-test, correlation. Okay, I don't have it. Okay, so if I don't have it, let's see if we can somehow add another one here. Okay. Okay, let's just see if I put gender here. Okay. Wait, let me. Okay. Okay, if you can see here, I will put gender here. Okay, and I will put 1 and 2, and label will be 1 is male, 2 is female. Okay, so this is okay. So we can look at the data view here, and let's say I just want to just like key in whatever 3. Wait. 2, 2, 2, 1, 2. Okay, let's say this is the data. So we have the first data here. Okay, first IV here, and we have the second IV here. Okay, so can everyone like key in the data just like what I've did now? Okay, add one more data gender in the existing before this that you've done before. Okay, I'll give you time to do that.
Doctor, is it I can is it you can turn back on the variable view screens?
Okay, variable view screen. All right. Okay, so let's change this. This is group. This is class size. Okay, so did it change here? Okay, so you can look at here. Okay. Okay, so this is the data view.
Saya buku teks. Cuma ada yang tak cukup. Cuma ada yang tak cukup. Mesti ingat yang tak cukup.
Okay, everyone done? Everyone done? Okay, done, eh? All right. So, wait, where is it? This one. Okay, so let's look at the two-way ANOVA analysis. As usual, go for analyze. Okay, go for analyze and pick the wait. Wait, let me see. We have to pick the general linear model and click univariate. Okay, click univariate and you can choose the, where is the dependent variable? Okay, this is the dependent variable. Okay, this is the dependent variable. Okay, and put the group and gender here. Okay, put the group and gender here. Okay, so under the fixed factors, okay, okay, so you can click the plots. Okay, you can click the you can pick the plots here, okay, and then you can put the group in the horizontal axis and you can put the gender in the separate lines. Okay, and click add. So you can see here group versus gender. This is the interaction effects that we are trying to look here. Okay, everybody okay? Okay, so click continue. Okay, click continue. Okay, so you click post hoc. Next, click post hoc. Okay, wait. Why this is okay? Post hoc. Oh, supposed to be there. There should be the group versus gender here. Wait. Okay, it's okay. So here you can pick the group here. Okay.
Penilaian.
And then you can keep the two key. Okay, two key. Continue. Okay. And then you can click the what do you call that, options. Okay, click options. Okay. So here you can see if you want to do the homogeneity test or descriptive statistics. Okay, so you can see if you want to do whatever test that you want to do. Okay, usually we will look at the homogeneity test, descriptive statistic and so on lah. Okay, so next you can click OK. Okay, and then you will get this result. So here you can see there is a descriptive statistics. There is a living test of equality of error variances. This is where you want to see if you have homogeneity of variance or not, whether your variance is similar or not lah. Okay, so this is the descriptive, this is the living test, the variance test, and this is where you want to see the what do you call that, test of between subject. Okay, test of between subject, and this is the multiple comparison, which is the post hoc. Okay, so let's look at this first. Okay, let's look at this first. Test of between subject. Okay, if you look at here, the group, this one, can you see the line that I have that I show here? Okay, you can see this is the main effect for group. Okay, this is the main effect for group. So this is the significant value, which is 0.12. Okay, 0.12 meaning that there is significant or there is no significant difference. 0.1. 0.1.
No significant difference.
No significant difference. Okay, you can see for gender, there is significant or there is no significant difference.
Ada banyak.
There is a significant difference.
There is.
A significant difference.
Are you sure?
Oh, wait.
It's more than 0.05. It's
No
more than 0.05. There is no significant difference or there is significant difference.
There is.
There is significant difference.
Hari ni pakai kasut with no sock hari ni. Kau ni.
There is significant difference. Yes. If more than 0.05, meaning that there is no significant difference. Okay. If there is less than 0.05, then it means there is significant difference. Okay. Which is why if it is less than 0.05, we rejected the null hypothesis. Okay. If less than 0.05, we reject the null hypothesis, meaning that there is significant difference. Okay. So please remember, less than 0.05, there is significant difference. More than 0.05, there is no significant difference. Okay. So if we look at here, the group versus gender, the interaction effects, the significant difference is also more than 0.05, showing that there is no significant difference. Okay, there is no significant difference. Okay. Okay, so if you can see here, this is the test of between subjects. Okay, this is the test of between subjects. And if you can see here, it doesn't show that group versus gender and things like that. There is what do you call that? Which one have significant towards who, and because in group and in gender there are several groups, because group and gender is the factors, is the independent variable, and in the group we have another groups here. Right, set 1, set 2, set 3, gender, we have male and female. So if we want to see in detail, okay, in detail, like if let's say math and English, math and history, English and math, English and history, like more what do you call that? Let's say if you want to see between math and English, is there a significant difference or not? Math and history, is there significant difference or not? If you want to look at that much more, what you call that, in detail, let's say, if we can see here, math and English, if you look at the interactions, it is not significant. Math and history, it is not significant. Okay, if you look at here, English and history, it is slightly not significant because it is 0.06, which is a bit higher than 0.05. So if you look at here, the interactions between the groups is actually not significant. So what we can conclude here is that there is no significant difference between groups, okay, in this analysis, because every analysis is showing that the significant difference is more than 0.05. Okay. All right. So let's look at this again. Okay. So can you see here? Okay, you can see here, if P is less than 0.05, meaning that there is interaction effect. And this one you can see here, okay, you can see here, meaning that there is a significant difference. Okay, there is a significant difference between education level here. Okay, let's say we have how many? 3 education levels. So meaning that there is a significant difference between education level, which you can see here. Okay, this is the education level. You can see here, okay, the what do you call that? The p value is what do you call that? 0.001. Okay, even though this and this is not significant, but this is significant. Okay. You can also see this, okay, pairwise comparison. Okay, pairwise comparison is where you want to see between gender and also the education level. This is where you do the, what do you call that, the education level versus gender that I've shown you before, that we've said before, right? So you can see here that this this is significant here, okay, which is less than 0.05. So how to report, you can see here lah, how to report, okay, F, okay, 2 groups, two factors, not 2 groups, 2 factors or 2 IV, and 54, okay, 54 is the sample lah, okay, this is the F value and this is the P value, okay, this is the P value, okay. P value is you take from here lah. You take from the interaction effect here. Okay, which is 0.014. Okay, so this is this is how you do the two-way ANOVA. Okay, the two-way ANOVA. So you can see here. Okay. Wait, this one. Okay, if the interaction is not significant, okay, it's not significant, meaning that there is no significant difference, okay, then we conclude the main effects. The main effects are independent of one another. Meaning that the main effect is maybe another group is not somehow what do you call that, dependent of another group lah, meaning that both group is not giving any effect towards the other group. Okay, so meaning that here the effect of factor A is consistent regardless of what is happening with factor B. This is what we mean by not statistically significant. Okay, if P is more than 0.05, just like what we've seen in the SPSS statistics just now. Okay, so we can then test for the significance of main effects separately. What does it mean here is, first of all, when you get this data, you have to look at the interaction effect first. This one. If the interaction effect is what do you call that? There is an interaction effect. Okay. Usually we don't look at the main effect. We don't look at the main effect. Okay. So you can look at this pairwise comparison and the two key analysis. If you have the what do you call that, interaction effect. Let's say if your interaction effect is less than 0.05, then no need to look at the main effect. Meaning that this one, you can just disregard this. Okay. But if let's say your interaction effect just now, like I've shown you in the SPSS just now, the interaction effect is not significant, right? It's not significant. Okay, so you can see here, the interaction effect here. Significant is 0.6. So it's not significant. Then you can look at the main effect, group and gender. Okay, that's what I mean by if the interaction is not significant, just like what you've seen here is more than 0.05, then you can look at the main effect, group and gender just now. Okay, so okay, wait. Let me share the screen again. Yes? Yes, any question?
Doctor,
Uh-uh.
for the reporting part,
Uh-uh.
can I know like where is the 54 from? The F
The
to
reporting part, wait, let me see. Let me scroll down where is it?
yeah, this one.
Yeah, this one. Okay.
Reporting part.
Yeah, the DF. Degree of,
Oh,
okay, the degree of freedom. This one. If you look at the data, okay, the data, you can look at this part, error, this one. Okay, because total is 60. Okay, total is 60, but you have two factors here and things like that lah. Okay, so there is a calculation actually how to calculate the DF, like I've mentioned in this part. Where is it? Where is it? This one. Yeah, this one. Okay, degree of freedom. Okay, so but you don't have to learn that. You don't have to learn that. You can only take this part. Okay, this part. Wait. Okay. Yeah, this part. Error 54 here. The degree of freedom. Okay. 2 meaning that you have two groups. Or not two groups, but two factors. You have two independent variable. If you have 3 independent variable, then you have to write 3 lah here. Okay. Alright.
and then for the 4.643,
4.643 is the value of the F statistics. Where is it? 4.4. Where is it? It's here. Wait. This one. F statistics. Can you see here? This one. Oh, wow. Wait. Where is it? This one. Yeah. This one. Okay, for the F statistics. Okay. And P 0.14, you take from here. Oh, it's too much. I have to delete here. You take from here. Okay, you take from here. This one. Okay. Okay. So any other questions? Okay, like I said before, if the interaction effect is significant, meaning P less than 0.05, you don't have to look at the main effect. You can do the pairwise comparison analysis like this part. Okay. This one is already in the SPSS when you do the what do you call that analysis using SPSS. You can look at here, it writes as pairwise comparison. Okay. So you can see lah here, school mail significant or not. So you can report only university male and female is significant. Okay. But school male or female is not significant. College male or female is not significant. University male and female is the only significant one here. So you can conclude that there is a significant difference or there is a significant interaction effects between university student, either it is male or female, something like that. Okay. So that is how you do the two-way ANOVA. Okay, any other questions? Okay, if there's no question, maybe we can take a break for 10 minutes before we start again. Okay, until 11:20. Okay.
Doctor, you're still sharing your screen.
Yes, it's okay.